Okay, so question 11 has A is negative 3, 1, B is 5, negative 4, and C is 1, 6. Okay. Okay, so we want to know, first of all, the coordinates of A plus B minus C. So what I have is the x component will be negative 3 plus 5 minus 1. And that's a plus 1. And then y would be equal to 1 plus negative 4 minus a 6. And this ends up being negative 9. Okay. And then the magnitude, so now we have basically this new vector, which let's call v. V is equal to 1, negative 9. Its magnitude, so the magnitude of v, is defined to be the vx squared plus vy squared. So that's the square of the vectors here. So I'd have 1 squared plus negative 9 squared. This ends up being the square root of, that's 81 plus 1 is 82. So it's going to be just a little bit above 9, which makes sense given that the bulk of that is in the 9. So let's just do that. Square root of 82 is at 9.05 or so, 9.06. Okay. Find the angle of A plus B minus C as measured counterclockwise and positive x-axis. Okay, so what we have here, and I should have probably done this here even before going to the magnitude, but that's all right. So I have 1, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's mostly here. So this is the way this vector is, all right? The length of it is this magnitude, and notice it's just a little bit bigger than just straight down, just because it's 1 over and like mostly down. So that's the reason why it's that way. Now, which means that its angle, this little angle here, which I'll just call A, is going to be really tiny. All right, and the tangent of that A would be the opposite, which is 1 over the adjacent, which is 9. All right, and so then I can look at the arctangent of 1/9. So so inverse tangent of 1/9, and this should be a pretty small number. Yeah, 6.34 degrees. Now, a couple of things. I could have done the arctan of the opposite. So sometimes they do. Sometimes you see it as the y component over the x component. So sometimes you see that, right? And if we look at that number, and we'll even do the minus sign just for to kind of show this. So if I do the arctangent of, say, negative 9 over 1, oops, let's see, arctangent of negative 9 over 1, notice I'll get, so if this is, and I'll call this angle little b, just what I call that one little a. Okay, I got negative 83.65, almost 66. All right, degrees. Now what is that? Okay, so that angle is, if you build this one down, that angle is this angle. So this is angle B, right? And they add up. You can add them up, and they're 90 degrees. And so it just depends on which one you're interested in. Now, if it's, and so this one as measured counterclockwise from the positive x-axis, depending on how you want to do this, sometimes they want a particular thing. This is why I always do a diagram, because I can say, okay, I can point at that. That's the angle that I'm talking about here. This is the angle that I'm talking about here. But if you want like this angle, so we'll do all the way around to here. All right, if we want that angle, I'll call that little c. All right, because of the picture, I happen to know this is like 90 degrees, 180, 270 plus the a, right? So this is 276.34 degrees. Again, these are all the same quantity, and we're just going from the diagram to do this. Okay, now if I want to draw a picture of the vectors and kind of redo this one, let me try to do that as a separate diagram, and I'm still going to do it a little bit roughly. It'd be probably good to have maybe to have a ruler for this to see. Maybe I'll get a ruler. Okay, so I have a ruler, and so let me actually draw out my grid here, and just to kind of get something that's at least a little bit sensible to scale. I can do this, probably roughly anyway. Again, A is -3, 1. B is 5, -4, and C is 1, 6. So let's start with A, and I'll just do -3, 1, puts it at -3, and I'll do 1. So that is going to be right about here. And so A looks like something like this. There's A. Okay. Now, let me do B. B is 5, -4. So -4 is over here. It's actually, sorry, -4 is down. Sorry about that. So -4 is down this way. So that's my -4. And then 5, so this is almost going to be a 45-degree angle. So 5 and 5, and then -4 basically straight down would look like this. And so B would look like this. Okay, so this is B. And then C is 1, 6. So C is 1, and then we're going to go up 6. There. C. Okay. So if I want to add two vectors, these are somewhat inconvenient from a picture point of view. But what I can do is I can follow the parallelogram method, which essentially says, okay, if I'm going to take this vector, and this vector is about a magnitude of about 6.5, and you could probably figure out that that's the magnitude of B, and then I'm going to do this. I'm going to take it. I'm going to put it over here, and I'm going to go 6.5, and do a parallel to here. So imagine I'm just making a little parallelogram out of this, guys. Okay, and then this. So this is, imagine that this is kind of a mapping of B, and then this one part of it, the parallelogram, should be a mapping of A. So it should look exactly like this, and essentially it will be 3 over and 1 up. Just like that one is. So I'm just going to draw this line here. Okay. And so what's happened is I've taken this and I've added this, and so I make this vector here. This vector here is A plus B. All right, so you just the kind of the parallelogram. Now I want to do, but I want to do a plus b minus c. Now this is the same as saying a plus b minus c. So I can start with that vector. That's a plus b. But I can do a plus b plus negative c. Right. So these are all the same. And negative c is essentially this same vector here, drop down onto this side. And we're going to go, so imagine I'm just going to do a dashed line here, all the way down here. It's going to end about here. It's going to be 6 down, so it'll end about here. And this is negative c. That's what that is. And so now I can add these two vectors, and we can do the same thing as we did before. We can take this vector here, which seems to have a length of about 3 3/4 or so, and then I'm going to displace it down here and make it parallel. Okay, and that will be something like this, and about 3 3/4. It'll be kind of something like this. If I can do it with this picture. Just keep that parallel. Do this. I'll get the length in a second. So that's the roughly parallel and about almost 4 of a length. To 4, maybe about here. Okay, and then I could do the same thing here if I wanted to, and this should be parallel to that. So I can make a parallelogram, and then the final vector, this final vector v, which is the sum, it's the same as this, is from here to the point of this here. And what you'll notice is that v is basically like negative 9, that's equal to about 1 over in x, and negative 9 in the y, right? So even from a picture, so you can kind of see from a picture this maps onto here. Now some parts of this are a little easier to do than others. Some vectors are a little easier to do the parallelogram method if they happen to not be quite so, like these two are almost parallel, so they're a little hard to draw. But and subtraction you can always just change it into adding by mapping that